No. So in this video, we're going to do the last three problems of these notes for trigonometric identities, and I've saved the longest for last here. So here. It's really a toss-up of which side you want to start here. You want to start with. So I'm just going to start with this one, and the reason for this is that when you see a fraction like this, you have 1 plus something over 1 minus that same something. You can always do this little conjugate where you multiply and divide by 1 plus something, so the denominator will become much simpler. And so in this case, we have 1 plus sine theta, or 1 minus sine theta. This is equal to 1 plus sine theta, or 1 minus sine theta. And I'll multiply by 1 plus sine theta over 1 plus sine theta. And then you have, this denominator just becomes 1 minus sine squared theta. And this, if you multiply the product of the numerators out, you get 1 squared, which is 1, plus 2 sine theta, plus sine squared theta. And then by the fundamental trigonometric identity, the denominator has to be cosine squared of theta. Okay. And in fact, we can actually, we didn't really have to multiply this out, because we can keep the bottom here. This, I should say, is still 1 plus sine theta, quantity squared, right? So this is really going to be the square of 1 plus sine theta over cosine theta, quantity squared. Then if you just simplify with what's in here, in the parentheses, is 1 over cosine theta plus sine theta over cosine theta squared. So this will be secant theta plus tangent theta, quantity squared, which is exactly what we wanted to do. Sorry about this. You could multiply this out. You didn't have to multiply this out. You could have just kept this. You could have just kept this as 1 plus sine theta squared, and that would have been fine. All right. Let's look at 15. Once again, we'll start. This is the more complicated side on the left, so we'll start there. And all right, so a couple of ways here. You might see the 1 and the tangent squared, and you might want to think, oh, okay, is there a secant squared in here? Well, if it was 1 plus secant squared, or I'm sorry, if this was 1 plus tangent squared, obviously you want to replace it with secant squared. But it's 1 minus tangent, so you can't really do anything with that. We can't put a secant in here yet. And also, in case there's no secant in this equation, so it's probably, you don't want to introduce another trig function if you don't have to. Instead, why don't we just replace tangent with sine over cosine? So this will be cosine squared of theta minus sine squared of theta, for 1 minus sine theta over cosine theta squared. All right. And then this is going to be, this will be cosine squared of theta minus sine squared of theta over 1 minus sine squared over cosine squared. And just to see what happens, smooth things out, I'm going to multiply and divide by cosine squared. And the reason I want to do this is because then this, and in fact we want cosine squared because we want to cancel this cosine, and then that will, something kind of nice will happen. Because then you'll have cosine squared minus sine squared, and you already have a cosine squared minus sine squared over here. So this is going to be cosine squared minus sine squared, put that in parentheses, times cosine squared. And then over here we have cosine, if we distribute, cosine squared minus sine squared. Okay. And then something very nice happens, right? These factors cancel, and we just get cosine squared, which is what we wanted to do. All right, and then the last one here, I haven't said what A and B are. You can just assume that they're any real numbers, or in fact, you could even make them complex numbers if you want, I guess. And for this, you want to show, okay, well, let's grind it out, just multiply things out. You don't have a whole lot of options. There's no real common factor you can factor out, so let's just multiply this out. And just remember, when you multiply out something like x plus y squared, this is x squared plus 2xy plus y squared. So you want to, don't forget the middle term here. So this is equal to a sine theta squared plus 2a sine theta b cosine theta plus b cosine theta squared. Okay, so that's what this is. And then this is something minus something else squared. So in that case you have, x minus y squared is going to be x squared minus 2xy plus y squared. So this is going to be plus a cosine theta squared minus 2a cosine theta b sine theta plus b sine theta squared. Okay. All right. So first of all, hopefully you see that this term and this term are the same. So these cancel out. And then what's left is you get a squared sine squared of theta plus b squared cosine squared of theta plus a squared cosine squared of theta plus b squared sine squared of theta. And if you rearrange the terms so the a squared terms are together, and the b squared terms are together, and you can factor out an a squared and factor out the b squared. Okay. I think you can see something very nice happens. We use the fundamental identity, say that this has to be 1, and so this is 1. So this is going to be a squared times 1, or just a squared plus b squared times 1, or just b squared. Okay, so really just a lot of algebra and a lot of clever substitutions. The only way you get good is practice, practice, practice. So I've got a lot of problems for you to do on the homework. So go back and look at these examples, look at the videos, pause them if you don't need to, and any questions, just email me, and I will see you next time. Bye.